Good morning, everyone. This is Mrs. Hoban. This week, you're going to have two sets of notes and practices to go through. So, between now and Friday, you just need to make sure you get this stuff done. Basically, how it's going to work is I'm going to go through the notes for y'all in a video, and you can either print out your own copy and write on it. You can type on it on your computer if you'd like to, or you can just take the notes on a separate sheet of paper. Okay, so we're just going to jump right into this. The first lesson for our circles unit is Intro to Circles. So we're going to go through some vocab and stuff. I'll also be posting the key to the notes after the video, just in case you missed anything or anything like that. Okay, so first things first, the definition of the center of a circle is all points on the circle are equidistant from the center. So let's say that I have a point, and all of your circles will have a point in the center. Let's just pretend like that's in the center. And let's say that this is labeled point A. Okay, so the center of my circle is point A or B or C or whatever it might be. Okay, the radius, I know we all know what this is, a line segment from the center to the edge of the circle. So it is a line segment. Let's say I make that point B. We would label that AB with the straight line over top, no arrows on either side because it is a segment. Okay, the next couple of vocab words are probably going to be new to you. You might not have heard these before. So the first one is a chord, and that's a line segment whose endpoints lie on the circle. So literally any 2 points that you could pick on the circle. Let's say I pick those two. I'm going to label them C and D. Okay, so the chord is the line segment that connects those. So it doesn't have to go through the center. It's literally just connecting 2 points on the circle. Okay, again, it's a line segment, so we use the 2 points with the straight line over top. All right, now a secant is very similar to a chord, but it is a line that intersects the circle. So let's say I extended this into a line, it would be the actual line that went between those 2 points. So we do include the arrows on the top of that. Okay, so that's the only difference. Chord is the line segment, secant is the actual line. Okay. All right, a tangent line is a line or line segment. So this one can be either that intersects a circle at exactly 1 point. So this one's a little bit weird, but let's say I pick a point on the circle and I'm going to label that E. Okay. I'm going to have a line basically that only touches the circle at that point. It's not going to go through the circle. It just touches at that point and continues on in both directions. Now again, it could be just a line segment, but typically it is a line. So I'm going to make another point on that line F just so that I can label this EF, 2 arrows, because it is a line. Okay. Again, technically it could be the line segment. So, but most of the time it is going to be the line. All right. Now the point of tangency is just the point when it touches the circle. So in this case, it would be point E. Okay, I know that y'all all typically know what a diameter is, the segment that has endpoints on the circle and it has to pass through the center. So let's say my center is here. Any diameter would go from one end to the other, but it does have to pass through. Okay, so where am I at on the alphabet? G and H. My diameter would be segment GH. Okay, circumference is the length or distance around the circle. Okay, there are formulas for that. So the circumference of a circle is either equal to pi times the diameter of the circle or 2 times pi times the radius. Okay. Now an arc, again, this is new. You probably have not heard of this unless you've already been doing the Khan Academy practices. So an arc is the portion of a circle between 2 endpoints, okay? So just like with a chord above, it can be any 2 endpoints on the circle. So let's go back to A and B. Okay, so I have my 2 points A and B on the circle. Now the arc is not a straight line connecting those. It's this entire distance around the circle that connects A and B, okay? So our notation for this is going to look a little bit different. Instead of it being a straight line above A and B, I'm gonna put a curved line above A and B. So that is talking about the arc between A and B. Okay, now when we talk about the arc, the letters, we are always taking basically the shortest path from A to B. Okay, so this, if I'm labeling arc AB, it is not from A all the way around here to B. It is the shortest path from A to B. Okay, so for the next part, there are 3 different types of arcs. There's a minor, a major, and then a semicircle. Okay, so a minor arc is an arc on the circle whose measure is less than 180 degrees. So hopefully we all know around the whole circle would be 360. So if it's less than 180, it's got to be just basically less than half of your circle. Okay, so for example, in this one, from L here to Y, that would be less than half of my circle, so that would be a minor arc. Okay, so that is one example from L to Y. Again, arcs, we have the curved arrows over top. Sorry, curved line over top. So L to Y would be a minor arc. Okay, now for a major arc, it is a measure that is greater than 180 degrees. So let's say I want to talk about this arc from L all the way around my circle here to Y. Okay, so it's still from L to Y, but I'm going the other way. I'm talking about this entire part. Okay, for a major arc, this is very important. You need to use 3 letters to determine your major arc. Okay, so in this one, we're starting at L. Okay, then I'm going through point U. So that's going to be the middle letter. And I'm ending at point Y. So L-U-Y. And then I'm going to put my arc over the entire thing. Okay, so for a major arc, because normally an arc, when we name it, is talking about the shortest path between those 2 points. If I want to talk about this longer path between L and Y, I have to include that point U in the middle. So my arc is L-U-Y with the arc over top. Okay, and then a semicircle is an arc of the circle whose measure is 180 degrees. So it would just be basically like halfway around your circle. Now there isn't a semicircle in this picture, but let's say I extend this line. And I'm going to make that a K over here. Okay, so let's say that this is a diameter of the circle. So from K to Y or from Y to K, that doesn't matter. That would be a semicircle. Okay, we only need 2 letters because no matter which path I take, it's going to be the same distance. 180 degrees is halfway, so I don't have to use 3 letters for a semicircle, just 2. All right, a few more vocab words. So central angle and inscribed angle. This is going to be important a little bit later on in this unit, but just so you know what it is for now. A central angle is an angle whose vertex is on the center of my circle. So let's say I've got my center and then I've got maybe 2 points on my circle here. Let's call them A, B, and C. Okay, so the central angle, if I connect these two, okay, the central angle is going to be the angle created by those two, me drawing the 2 radii. So from A to B and then from B to C, I've got those 2 radii drawn, all right? And then the central angle is on the center of my circle, okay? So angle ABC, so I know which one I'm talking about, would be a central angle, okay? Now an inscribed angle is an angle whose vertex is on the circle, it's on the edge of the circle, okay? So again, let's say I have 3 points, but now instead of one being the center, they're all gonna be on the circle. Let's make these D, E, and F, okay? So if I connect these, the inscribed angle is the angle created when I connect those 3 points. So it would be that one right there. Again, labeling this correctly would be angle D, E, F. Okay, so central angle, it's on the center. Inscribed angle is still inside the circle, but my vertex is on the edge of the circle. Okay, congruent circles, I know we know what this means. They would have the same radius. So let's say this one has a radius of 2. Any circle with also a radius of 2 would be congruent to that. All right, and then concentric circles are 2 or more circles with the same central point. So one is smaller than the other, but they have the same central point. All All right, so let's look at some examples. All right, we've got this circle with kind of a lot going on in here, a lot of points, a lot of lines. We're gonna go through and we're gonna give an example of each of the following things, okay? So the center of my circle, all right, pretty easy. Center right here is point J. Okay, now there are lots of different options I could have for the radius of this circle. Remember, the only thing that needs to be true is it goes from the center to the edge. So I could do JF, JE, JA, really whatever you want. I'm just gonna do JF since it's the first one I said. Okay, again, radius is a line segment, so straight line over top. Diameter, again, we've got a couple different options for this one, but it just has to go all the way across the circle and go through the center. So from A to F would be a diameter. Again, line segment. I'm gonna put the straight line over top. All right, a chord that is not a diameter. Remember, a chord goes from one point on the circle to the other, but doesn't have to go through the middle. It could, but it doesn't have to. So this line right here, CD, would be an example of a chord that is not a diameter. Again, chord is a line segment, so no arrows on my notation. Now a secant is just like a chord except for it is a line. Okay, so this one right here would be an example of a secant, HG. Again, it is a line, so we have those two arrows, and this one does continue on in both directions as you can see from the picture. All right, a tangent is the line that goes through just one point on the circle. So my line right here only touches my circle at one point. I do have that other point on there just so that I can give the notation for that is BK. All right, point of tangency is just that one point when it goes through my circle. So in this case, it would be point B. Okay. All right, now our arcs, minor arc has to be less than 180. So as long as it's less than halfway around your circle, you can pick whatever you want, right? Just to make this easy on me, I'm just gonna pick a really, really small one here. So from L to A, this arc right here, that is less than halfway around my circle. So again, for the arc from L to A, the only difference here is I'm putting a curved line over top of my notation. Okay. All right, now a major arc, remember this is more than halfway around your circle. So I'm gonna go the other way. Let's say I'm still starting at A, but I wanna go all the way around my circle here. Again, I've gotta go more than halfway around. So let's say I'm gonna go all the way to G, okay? So from A to F would be halfway, and then I'm gonna go just, I guess, a little bit more to G, okay? Remember, for a major arc, we need 3 letters. So I'm starting at A, all right? And I can pick any of these points along the way to G, okay? So let's say I'm starting at A, I'm gonna go through, let's say I'm gonna go through D. Now, I could pick any of those. Let's just say I pick D, okay? And then I'm gonna end at G, and I'm just gonna put my curved line over top, okay? You could have done A, B, G, A, C, G, whatever, as long as your middle point is somewhere along that path from A to G, okay? Semicircle, remember, is exactly halfway, so just pick one of your diameters. So from A to F is the diameter that I chose up here, but this time it's an arc instead of a line segment. Okay, now last part for the measures of arcs, okay? The measure of an arc is equal to the central angle, okay? So I'm just gonna write that over here. The measure of your arc is equal to the central angle of that arc, okay? So if I'm trying to figure out the measure of arc FE from here to here, okay, the central angle from F to E is already labeled as 30 degrees, okay? So that means that this arc is going to have the same exact measure. It's gonna be 30 degrees, okay? All right, and then the measure of angle FEL. So all the way from here to here, okay? So if I look at my picture just from E to L, that is halfway around my circle, Okay, so that central angle right here, this entire thing here, would be 180 degrees. Again, halfway around my circle is 180, right? So if I'm going from here to there, okay, I've got the 30 already from here, and then I've got the 180 from the rest of it. So I need to add those two parts together. 180 plus 30 is going to give me 210 degrees. So from F all the way around to L is going to be 210 degrees.